Hey guys, in this video I'm going to go through this Leetcode number 207 course schedule, and we are given a total number of courses and that we can take and label from 0 to a number of courses -1. So we are talking about indexes, and also we are given an array of prerequisites, and the prerequisite looks a bit weird because let's say if A and B, so B is the prerequisite of A, right? As you can see here, the format looks like this. So 0 and 1. So 1 is the prerequisite of 0. So we have to take 1 first, and then we can take the 0 and return the true if we can finish all the courses. Otherwise, return the false. So as we can see in here, the prerequisite is 0 and 1. So 0 is prerequisite of 1. So we have number of courses 2. And we can do that because we can first take 0 and then take 1. And in this case, there are two number of courses 2, the same as last one, but 0 is a prerequisite of 2, 0 is prerequisite of 1, and also 1 is a prerequisite of 0. So there's a little bit of a cycle in here. That's why we cannot complete these two courses. This question was very popular. As you can see, it was asked by so many companies, and I'm gonna solve this question by using DFS. Let's dive in. So we first need a dictionary that keeps track of all the prerequisites. That will come in very handy. We can have a prereq and is equals to dictionary. So the key is the course, and the value is the list of all the required prerequisites. For I in number of courses. Sorry, that was not the right way to do it. I think the correct way is like this. Course is a key, and the value is empty dictionary. And then so this is how we initialize the dictionary, the prerequisite dictionary, and then now we can fill it all out. So for prereq, I think I think that just goes like this. So the course and the prereq in the prerequisite, and then that dictionary goes like this. Dot append that prerequisite course. Okay, so we finished the prep work that initialized the dictionary, and then now we can do a DFS. Also, we need a set that keeps track of what kind of course that we are taking. So taking equal to set. So this keeps track of the courses that we are planning to take, and also all the prerequisite that it comes along. because we have to take all the prerequisites before we can take a particular course. And so we can, same as other iterative function. And the first thing we can figure out is the termination condition. So if a course is already in the taking set, that means we detect the cycle, and that's automatically returns a false. And so basically we detect a cycle. And for all the prerequisite in so all the prerequisite of this particular course that we are taking, we do a bit the DFS in it. And because we are taking the course, we adding the course to the taking set. Sorry, it should be prerequisite. Okay. And also another condition is if the prerequisite dictionary is a empty list, that means there is no prerequisite for this particular course that we are taking. That means we can take that course. We can automatically return a true. So let me walk through an example in here to show you how we can detect cycle by using this DFS. This code has not yet finished, but I just want to go through that with you first. So let's say if we have a prerequisite looks like this. So in that case, the prerequisite of 1 is 0, and also prerequisite 0 is 1. So there's a cycle in here. And when we run the DFS, we first can run through the course. Well, it doesn't matter which one, but let's say we run the course 0 first. And when we run it here, and the course 0 is not yet in the taking, that's why this if statement will not be executed. And also the prerequisite is not empty list, so this line will not be executed. So the taking, now the taking set contains a 0 because we are taking it. But before we taking the course, we gotta take all the prerequisite of 0. In this case is 1, right? So at the same time, we will run the DFS on 1. And then, so 1 will be the course right now. And 1 is not in the taking set. That's why this line will not be executed. And also, the prerequisite of 1 is not an empty set. That's why these two lines will not be executed. And now, the taking set will contain both 0 and 1. And then we will go to here. And this line is adding 1 to the taking set. And then for all the prerequisite of the course 1, which is 0, so we will do a DFS on 0. However, 0 is already in the taking set, right? So we return a false. And then that's how we can detect a cycle in here. So after we finish all the prerequisite, after we run through the DFS on all the prerequisite, and we can take that course, and after that we complete the course. So the taking can remove that course because we already taken that course, can complete that course and all the associated prerequisite. And also that prerequisite dictionary can become 0 because all the prerequisite has been finished. Okay, so this DFS function is complete. So what we can do is call it for all the courses, for course in range num course, and we can do a DFS. This is how we can trigger the function running. And if we can finish all the courses at the end, if the taking set is empty, because we will move all the course by using this statement, that means we can complete all the courses. And in that case, we will return the true. Otherwise, we will return the false. Sorry, I missed a condition here. So if the prerequisite is not, the DFS on the prerequisite is not true, and we will return the false. That means we cannot fulfill the requirement for the prerequisite. That means we detect the cycle. Okay, I run for the test case. Submit the code. Oops. Pause the recording to. Okay, it runs this time, and I put one more condition here where if the DFS is not equal to true, means it's false, and returns a false immediately. So it terminates the entire function immediately. So yeah, that runs. As you can see, that's the efficiency. Sometimes not reliable. If I submit again, maybe yeah, it's not very reliable. So in terms of time complexity, so it's a big O over E plus V. So V is the number of courses, and E is the number of the prerequisites. So same as in the previous algorithm, which I mean in the official solution, the previous algorithm is the backtracking. So same as backtracking, it takes big O over E complexity to build a graph in the first step. And then because we have to perform a post-order DFS traversal in the graph, we visit each vertex and each edge once and only once in the worst case. So it's a big it's a E plus V. So here is where we build all the relationships in the graphs, and here is how we traverse in the graph to detect the cycle. For the space complexity is a bit over E plus V as well. So we build a graph data structure in the algorithm which consume E plus V space. So basically it's talking about the dictionary, the prereq dictionary over here. And in addition, during the backtracking process, we employed two bitmaps, path and visit, to keep track of the visited path and the status of the check, respectively, which consumes 2 times V space. And actually, we don't have that. And what we have is only the taking set that keep track of what course has been taken or what not has been taken and what course is being taken. So that's why we can detect the cycle in there. And then that is the worst case scenario will be if everything is a prerequisite of another. So as a linear will be the big O of the number of courses in the worst case. Finally, since we implement the function in recursion, which would incur additional memory consumption cost, yeah, we have that as well. In the worst case, where we all nodes chained up in a line, yeah, so the recursion will not pipes up every time. So it's talking about this DFS function that we are calling recursively. Again, this function, the official solution is not exactly the same as the one that I'm writing in here, but a lot of complexity analysis is the same. And because the overall space that's why I'm borrowing this wording in here. Because the overall space complexity algorithm will be, yeah, so it's still applicable. So big O for E plus V. So that's so much for this solution, and I hope you like it. If you do, please like and subscribe. Hopefully I can see you in the next video. Thank you.